Hello, viewers. I'm Sunil Kumar. You are watching a lecture series on engineering graphics. Today's topic is projection of solids. In this video, we will discuss the basic concept. A solid is a three-dimensional object which can be classified into two categories, polyhedra and solids of revolution. Polyhedra are the solids which are bounded by plane surfaces, whereas the solids of revolution are the surfaces which are curved surfaces. Polyhedra are further divided into three categories: regular polyhedron, prism, and pyramid. Whereas the solids of revolution are cylinder, cone, and sphere. Regular polyhedra are the solids having similar and regular plane faces. Examples are, for example, cube. Cube is having 6 squares. Tetrahedron. Tetrahedron is having 4 equilateral triangular faces, and octahedron. Octahedron is having 8 equilateral triangular faces. Prism is a solid having same base and top separated by rectangular faces. Example is triangular prism, in which at the base there is a triangle, at the top there is a triangle, and these two triangles are separated by rectangular faces. Square prism, square at the base, square at the top, and separated by rectangles. Pentagonal prism, pentagon at the base, pentagon at the top. Hexagonal prism, hexagon at the base, hexagon at the top. And in all these diagram, we can see that the base and top are the same. Dimension is same and they are similar. If hexagon at the bottom, hexagon is at the top. Pyramid is a solid having a base, and each corner of the base meets at a point which is known as apex or vertex. Examples are triangular pyramid, square pyramid, pentagonal pyramid, and hexagonal pyramid. In all these figures, we can see that the base is a regular, whether it is a triangular, square, pentagonal, or hexagonal, and each corner of the base is meeting at a point. So, this is the property of a pyramid. Solid of revolution, three examples are there. Solid of revolution are the solids which are formed by revolving a plane figure. Cylinder is the example. And how the cylinder is formed? When we revolve a rectangle about an axis, then cylinder is formed. Cone is formed by revolving a right angle triangle, and a sphere is formed by revolving a semicircle about its diameter. So that's why the name solid of revolution. Important terms in these cases: for prism, for top and bottom, we use these terms. Yes. For corner, we can say these are the corners of the base, and these edges, the edge of the base, and these vertical edges are the longer edges or edges of the face. In case of square pyramid, this is a base, these are the corners of the base, and this is the side of the base or the edge of the base, whereas this is the slant edge, and this top point is apex. In case of cylinder and cone, we have the imaginary lines which are called generators because these lines are used to generate the curved surface. This is an example that when we use the three steps to solve a problem. If we have a solid which is inclined to both HP and VP, we should have to use three steps to solve such problems. In this example, you can see that we have a cone, and this cone is inclined to both HP and VP. So first of all, we have to make the front view and top view in such a way that the axis is perpendicular to HP. Then in the next step, the axis is inclined to HP, and in the third step, axis is inclined to VP. Similarly, in case of cylinder, first of all, the axis is perpendicular to HP. In second step, axis inclined to HP, and in third step, axis inclined to VP. So in 3 steps, we can obtain the final result. Yes, this is also a 3-step problem when the axis is inclined to VP and HP. First of all, the axis is perpendicular to VP. Then the solid is tilted towards VP and the axis is inclined to VP, and in third step, axis is inclined to HP. Similarly, in case of cylinder, first of all, the axis is perpendicular to VP, then axis inclined to VP, and then finally axis inclined to HP. So in 3 steps, we can solve the problem. Important questions. To represent a solid in orthographic projections, at least dash views are required. At least 2 views are required. A solid having 4 equal equilateral triangular faces is called tetrahedron. When the axis of solid is parallel to both HP and VP, dash shows the true shape of the base. Profile plane shows the true shape of the base. Differentiate between right and oblique solids. Right solids are those solids in which the axis of the solid is perpendicular to the base. But when the axis of the solid is not perpendicular to the base, then these type of solids are called oblique solids. Differentiate between prism and pyramid. We have discussed in previous slides that prism is having the same base and top separated by rectangular faces, but in case of pyramid we have only one base and each corner of the base is meeting at a point which is called apex or vertex. For any question or suggestion, you can contact me at my mail ID. Thank you.